Hi guys, welcome to this video. In this video, we are going to deal with a statistical problem, distributive statistics to be specific, where we looked at you will look at some parameters like the range, the average score, that is the mean score, standard deviation, the coefficient of variation, and the variance. Alright, so this is a problem of statistics. Alright, so in this problem, a table was given earlier where a geneticist measured the height of 10 maize plants in an F2 cell population and recorded the data shown in the table below. So the plants were identified and then their heights, their respective heights. So the first plant 1, had a height of 84 centimeters. And then it continued to plant 10, which had a height of 78 centimeters. So these are the questions. And we were so lucky that in this question, they calculated some parameters for us. A parameter like the sum of the pi, that is the sum of the p's, the observations, right? So they added the heights. So sigma pi represents the summation of the heights. That is 84 plus 120 plus 90 plus 120 all the way to all the way to 70. So when you do that addition, you're gonna get 1020. That is 1020. Then the sigma p squared represents the fact that they squared the observations. So the first one gonna be 84 squared plus 120 squared plus 90 squared all the way to 78 squared. So when you do that and you add the sum them, you're gonna get 107,918. So that becomes the sigma p squared. Yeah, we do those kind of parameters or we calculate for them so that we can be able to estimate some particular variables or in their parameters. So in the first question, you have to calculate the range of the data provided in the table. So this is the table. You have to calculate the range. And to calculate range is a measure of central dispersion. So to calculate range, we usually determine the highest number in the range of the distribution. The highest number in the distribution here is 131. That is exhibited by the fourth plant, and then the smallest um, number in the distribution is 75, which is exhibited by the ninth plant. So to calculate the range, you're gonna take the maximum number, and then usually the range consider the extreme values. So you take the maximum number in the distribution, then you take out the smallest from it. So from the formula of range is calculated as the greatest height minus the smallest height. So as said earlier, the greatest is 131 minus the smallest, which is 75. So you end up getting 56 centimeters. Then we move on to calculate the average plant height. So as I said earlier, average score is the same as the mean score. So the question could have equally asked you to calculate the mean plant height. So to calculate the average plant height, we use the sum of the frequencies, then we divide it by the total number of observations. So total frequency in this case is the sigma pi, which was 1020. Then the total number of observation represents how many plants are there. That is how many plants were measured, the heights of how many plants were measured. So plus 1 to plant 10, that is about 10 plants, right? 10 plants. So to calculate the average plant height, you just have to divide the sigma pi by n, which is the number of observation. So you get 1020 divided by 10, get 102 centimeters. Now let's move on to calculate the standard deviation. So to calculate the standard deviation, that is how every every observation differ from the mean. You we use the mean deviation. So this is the formula to calculate or to estimate the standard deviation. So the square root there covers everything. So it's actually the square root of sigma p squared I over n minus the mean squared. So we earlier calculated that the sigma pi over n is the mean. So we square that. Now, um, substituting the values of sigma p squared, which was earlier noted to be 107,918. Then you divide by that by the number of observations, then minus 1020 over 10 all squared. So when you take the square root of the outcome, which is the 387.8, you're gonna get 19.693 centimeters. So this is the standard deviation. Okay. Now to calculate the coefficient of variation, this is also a parameter that is calculated in terms of central dispersion. So to calculate coefficient of variation, we divide the standard deviation by the mean. So we earlier calculated the standard deviation and we calculated the mean as well. So we just do this division. 19.693 divided by 172. Centimeters and centimeters cancel out. You're gonna get a variable of a value of 0.190. So usually we convert coefficient of variation into percentage. So this is gonna be times 100. You're gonna get 90.3%. Now let's calculate for variance. The variance is more or less like the square of the standard deviation. So when you square the standard deviation, you get a variance. You can equally say that the variance is the what's within the square root. Okay, so if we in this question, for instance, we are not asked to calculate the standard deviation, to calculate for variance, it's gonna be sigma pi squared over n minus sigma pi over n or square, right? No square root, no square root. So to calculate for variance, you say the standard deviation squared. So the standard deviation is calculated at 19.693 centimeters. So square, we're gonna get 387.8 centimeters squared. And the square is gonna affect everything there. It affects the number and also affect the units. So the variance is gonna be 387.8 centimeters squared, right? So this is how we go about the question and estimate these parameters. Thank you for watching. And if you have not yet subscribed to my channel, please subscribe, like, comment, and share. Thank you.